we are given a DNA sequence. It's a coding strand of DNA right here, the 5 to 3 prime. I went ahead and gave us a template strand in the 3 to 5 prime, so it would make our transcription process easier. I've also laid out this transcripted mRNA strand right here for us. And we'll be translating this sequence to give ourselves our amino acid sequence. So we're going to be looking at point mutations for our coding strand of DNA. I'll start off with the missense mutations. So right here, up in our coding strand of DNA, we're going to have a transition point mutation, change this guanine into an adenine. And you'll be able to see that down here in our first mutation right here. I have it listed out. This G, which was a G, is now an A. So instead of translating for this amino acid, we'll have a different amino acid. This is a missense mutation. It just changes the amino acid in the sequence. And that is a transition point mutation because we're going from G to A. Okay, the next mutation we'll be looking at is a nonsense mutation. This changes it so the codon becomes a stop codon. And to illustrate this, I went and did another point mutation that is a transition. So our G becomes an A right here. G to A, it's purine to purine, it's a transition. So if you can look down here, we're only going to make one amino acid on the second mutation because our next codon is a stop codon. It was just UGG, now it's a UGA stop codon. Our third point mutation type is a silent type mutation. This codes for the same amino acid. So to demonstrate this, we are going to be changing this C right here to a T. That C to T is a pyrimidine to pyrimidine, so it is a transition point mutation. So you will see that this would code then for an A. So this UGC right here would actually be a UGU. Now UGU and UGC actually code for that same amino acid still. So this would be a silent mutation, a transition mutation. Last but not least, we are going to discuss the read-through point mutation. This is a change in the stop codon to a codon for an amino acid. It results in a longer protein. And so for this demonstration, we're going to be looking at this TGA up here. We're going to have a transversion point mutation from T to A now. So this is a pyrimidine to purine, meaning it's transversion. So this will code, instead of for a UGA, it will encode for an AGA. So you can see right here is our UGA, was our stop codon. Now, because of that transversion point mutation from T to A, we have an AGA codon right here, which translates for a different amino acid, not the stop codon. So now we're going to have a longer sequence, a longer protein, and these other codons right here are translated into their respective amino acids.